So today we're going to start a little bit of a new topic, and it's all about lines and the equations that lines have. And this first video is going to be about spotting the connections between the equations of lines and the graphs of those lines. But before we get going, what I want to do is get you a little bit of background knowledge that you're going to need. So let's have a look. So, from previous work that you've done, particularly on coordinates, hopefully you can remember the following things. This is the x-axis, that's the one that runs horizontally, and this is the y-axis. That's important to know which one's which. And if you've got a point on your grid, that has a coordinate which is how far along you are, how far along the x-axis you've gone, and then how far up you've gone in the y direction. So that's why our coordinate is x, then y. And if I plot a set of points and I connect them with a rule, like our line equations are going to be, I can describe how the y's are connected to the x's. And that's really what all our line equation stuff is going to be about. Now, with that in mind, remember it's always x, then y. If you can't remember why that is. Remember, coordinates are sexy because the x always comes before the y. So with that in mind, there's two other key points, and that is if you've got a point on the x-axis, then it's not gone up or down at all in y. So it will have a coordinate which is x, 0. Similarly, if you've got a coordinate on the y-axis, it hasn't gone along in the x direction at all, and so it's 0 along in the x direction, y, whatever your y coordinate is. And we'll see that coming back in a wee bit later on. Now, if we quickly jump over to the thing I gave you for the starter, let's have a look. So I'm going to start by playing around with the value for m, and hopefully you've had a go with this. So I'm not going to spend ages playing around with it, but hopefully you've had a go. Hopefully you've spotted if m is 0, we get a horizontal flat line. That's an important thing to note. And then as I increase m, our line gets steeper and steeper and steeper and steeper. So that number that comes in front of the x value here in this equation seems to relate to making this line get steeper and steeper. Now let's think for a second what this equation is actually doing. It's saying my y coordinate is 3 times whatever my x coordinate is. So if my x coordinate is 1, I'm timesing that by 3 and adding 1, and that gives me a y coordinate of 4, which is exactly what we see on our graph. If I take x to be 2, I do 3 times 2 is 6, add 1 is 7, I get 2 along, 7 up. So that's the connection between, or what the equation is trying to do is tell us how, if I go along by a certain distance x, how far up should I go? And we can see that this number at the front here, if we make that bigger and bigger and bigger, that's increasing how much we're timesing by, and so our line gets steeper. Now, if we move the C1, in fact I might just change m back to maybe 2. If I change the C1, we can see if we make C bigger, our graph's not getting steeper anymore, but it does appear to be moving up and down. Now, if I make C1, this is a key thing. We see we cross the y-axis here at 1. If I make C2, you'll see we cross the y-axis at 2. If I make C3, you'll see we cross the y-axis at 3. And the same's true if I make it minus 1. So if I take 1 off at the end, we can see that our graph crosses at minus 1. And that's really important. That point is called the y-intercept, where we meet the y-axis. So those are our key things that I want you to take away from playing with this little software. So I've summarized those right here. So plotting all the x-coordinates which fit a particular rule gives us a straight line. Well, certainly if the rule is y equals some number times x plus something. We've seen that the number that we use for m, that's the number that comes in front of x, tells us about the steepness of our line. The number that we've got in there, c, the thing that's added on the end of our equation, is where we meet the y-axis, and I had the special term y-intercept. Now finally, there's one more thing, and that's what happens if m is negative. So let's go back to our graph and have a look at that last one. If m is negative, we can see that our graph is going down from left to right. So if I start over here and imagine walking right, I'm going down along the slope. Whereas if m is positive and I walk from left to right, I can see that I'd be going up the slope as I go from left to right. So that negative means that we're going down from left to right. So those are some little starter things. We're actually going to use that to do some examples in the next little video.